Rationalization of Surds. When we have one surd on top of the other, like when one surd is a numerator and another surd is a denominator, so it's like we are dividing them, but what we actually do in surds is that we rationalize them. What I mean by that is this. Let's look at these examples. Example number 1, if you have root 3 over root 2. This in math means that divide root 3 by root 2. But under surds, we don't actually divide. What we do is we rationalize, because this root 2 here is a problem. Why it's a problem is that a surd is not expected to be a denominator. Don't forget in fractions, the number that is up is called the numerator, while the number that is down is called a denominator. But in surds, a surd should not be a denominator. So that is why when we have something like this under surd, we rationalize. That is, we make it rational. That means that this particular surd here is not rational. And the reason why it is not rational is because we have a surd as a denominator. So the question is, how do we rationalize surds? That is, how do we remove a surd from being a denominator? So what we do is that we take that denominator and we use it to multiply the numerator and the denominator itself. Whatever is here, use it to multiply both up and down. Don't forget that you can cancel them, that root 2 cancel root 2, and you will still be left with your original question, which is this. But if you follow through with what I have just given you here, you will see that by the time we get the final answer, we are not going to see surd again as a denominator, which is our goal. So this one will give us root 3 times 2. Don't forget that when you are multiplying two surds together, like root 3 and root 2, just make a square root for both of them. Put them under the same square root. And this one will be root 2, like this. That's square root of 2 times 2. So you can pair this. So the one there, you cannot pair them. So 3 times 2 is 6. The one you can pair, the one you have paired, you take one of them outside. There is nothing remaining under the square root again. So this becomes your final answer. And what have we achieved here? We have achieved something, and the thing we achieved is that the denominator here is no longer a surd. So, and when we do that in surds, we say we have turned an irrational surd into a rational surd. So we have rationalized the surd. Let me give you another example. If we have root 7 over root 10, if we are to rationalize this, you multiply both sides, both up and down, by root 10. So in this case now, here you have root 7 times 10, and here you have root 10 times 10. So we can pair this, but we cannot pair what is up there. So our final answer is going to be root 70 over, since you have paired this, so you take one out, and there will be nothing under the square root again. So this will be your final answer. So that is how we rationalize surd. Let me do one more. If we have root, okay, let's say we have a whole number. Let's say 3 root 5 over root 3. If we rationalize this, just take root 3 over root 3. So in this case now, when you multiply this and this, the whole number here, don't forget we have an invisible one here. Root 3 in math is 1 root 3. So 3 times 1, that's 3. Or if you cannot see, if you don't understand that there is an invisible one here, just say 3 is the only whole number here. So 3 will stand alone. Then root 5 times 3 will be 5 times 3, you can write 3 times 5, 5 times 3 and 3 times 5, they are the same in mathematics, so it does not matter which one comes first. And this one will be 3 times 3, as in you put the two of them under the same square root. Since you cannot pair this because they are not the same, so here you are going to have 3 root 15. And this one, you pair, you take 1 out, and nothing will be under the square root again, so you have 3. So this should have been the final answer, but there is something. You can see that we have 3 up and 3 down. In math, you cancel them. 3 up can cut 3 down. So the final answer here will be root 15. So that is how we rationalize surds. So let me just give classwork. Rationalize. Number 1, 4 root 3 over root 2. And number 2, 7 root 5 over root 10. Or let me even put 3 root 10. So try your best, get the 2 answers to the questions that are on the board, and type in your answer in the comment section. Don't forget, this is Math Made Simple by Steve. That's MMS by Steve. So like, share, and subscribe to our channel. Thank you very much.